All right, so in this desmos activity, we are going to look at graphing polynomials in standard form, which is going to require us to factor them so we can find our zeros. It's really going to put together everything we've been talking about over the last few weeks, okay, and ending with a graphical representation of the function. So when you're given a polynomial in standard form, you start identifying what do you know, right? So I know that the degree of this function is 3. That's odd. All right, so I know my end behaviors are going in opposite directions. Okay, so since my leading coefficient is negative, okay, the right end behavior is negative infinity, and the left end behavior is the opposite, so that's positive infinity. Okay, I know it's going to have 3 zeros. Okay, I don't know if they're all going to be real or not. Okay, okay, so I do know if, all right, it has to have at least one real. Okay, at least one real, and at most 3 real, okay, zeros. It can have at most 2 imaginary, okay, or can have 0 imaginary. Remember, imaginaries have to come in pairs. Okay, so 0, 2, 4, 6, but since it only has at most 3, it can't be 4, can't be 6. It's only 0 or 2. All right. Can it be factored? Well, that we don't know. That's what we're going to have to try. So it has 4 terms. I could think about factor by grouping. One factor by grouping will not work. All right. So I'm going to have to try the rational root theorem. Okay. Must try rational root theorem. See if factorable. Okay. So we're going to walk through that right now. So it says list all possible rational roots. Okay, so I have that typed in right here. So P over Q, it's plus or minus. All right, and then it's all the factors of 36. So 1, 2, 3, 4, 6, 9, 12, 18, and 36. Since Q, the leading coefficient, is -1, right? I don't need to put over 1, all right, because it's the same thing. All right, so these are my possible rational roots. Now I know I could have at most 3 rational roots, okay, or I could have 1 rational root, but so I need to figure out which ones are going to work. All right, and so to do that, I'm going to do some synthetic division. All right, and so I'm going to set this up here. Right, list out my coefficients: -1, 10, -33, and 36. Okay, and I'm just going to start from that list that was on the previous slide. So I'll start with 1. Okay, bring down that, multiply, add, multiply, add, multiply, add. All right, so 112 is a point on the graph. I'll enter that in over here. All right, so then I will try the next one. So I'll try -1. +1, 11, -11, it's -44, +44. And that adds up to 80. So over here, I got a point negative 1, 80. Right. And then erase that piece. Then we'll try 2. Negative 2, 8, 16, negative 17, negative 34. That's 2. So at 2, 2. Let's try 3. All right, so I get negative 3, 7, 21, negative 12, negative 36, and 0. So 3, 0 works. All right, and so now I have this quadratic down here. Add the x's back on, right? So I have negative x squared plus 7x minus 12 equals 0. All right, and so I'm going to divide everything by negative 1, get x squared minus 7x plus 12 equals 0. So if I factor that, I'm going to get x minus 4, x minus 3. All right, and don't forget about that one. I already have x minus 3. So my 3 zeros are x equals 4, x equals 3, and x equals 3. So that just means x equals 3 with the multiplicity of 2. All right, so as I come in here to type out my roots, all right, so x equals 4 and x equals 3 with a multiplicity of 2. So those are all 3 of my zeros right there. All right, so I got x equals 4, x equals 3 twice. So I get add to my table here 4, 0. So I got all these points right here. All right, and so this will help me graph because I know some of these points. All right, and remember the multiplicity means it's going to bounce off of 3. All right. Okay, so next slide. Okay. All right, so now we want to sketch this. All right, so we're going to use some of the points that we had on the previous slide, okay, to graph this. So let's first put our zeros. Okay, so we know there's a 0 at 3. We know there's a 0 at 4. All right, we know our right end behavior is going down. So we know this part's going to be going down. Okay, we know that this part is going to be going up. Okay, so some of the points that we had, okay, we had 2, 2 was a point. All right, what else did we have as a point? Is anything else going to fit on the graph here? 112, negative 180. Does not look like anything else is going to fit on the graph here. 112 would be way up here. Okay, so this graph, all right, is going to be coming straight down here. Going to come through 2, 2. It's going to hit this point. It's going to bounce. It's going to come back down and through right here. All right. That's what my graph is going to look something like that. Based off my zeros, knowing the multiplicity, knowing the end behaviors, I could sketch a graph. Okay. All right, now it wants me to type it in factored form. All right, and so I had factored form on the previous slide there. Remember, it was x minus 3 squared and x minus 4. Okay, and it had a negative leading coefficient. So you can see that it matched. All right, and so we could write standard form, we could change it to factored form, right? And then we could find our zeros, okay, and take what we have about those. Another example, okay, list what you know given g of x. So here g of x is a 4th degree. Okay, so 4th degree polynomial, leading coefficient is positive. So both end behaviors are going up. Right, remember, even degree means same direction. Okay, so both left and right end behavior go towards positive infinity. Number of zeros, there's going to be 4 zeros. Again, that's just the fundamental theorem of algebra. Okay, but we don't know if they're real or imaginary. Okay, but what are our possibilities? So for real zeros, okay, I can have none. And so real zeros can be 0, have 2, or 4. All right, and then imaginary is the same. Right? If there's 0 real, then there's 4 imaginary. Right? If there's 2 real, then there's going to be 2 imaginary, and if there's 4 real, there's going to be 0 imaginary. Right? And then can I factor this? Again, same as last time. It says has 5, so I need to check with the rational root to see if I could factor it. Okay, use rational root theorem to see if it is factorable. Right? So that means I'm going to have to list, okay, my P over Q's right here. So P over Q, right? And again, put plus, minus. Again, it doesn't let me type it in there. So this one's just all the factors of 9, so it's not quite as many. So 1, 3, oops, not 23. 1, 3, and 9 are my only possibilities here for this one. Okay, so that's way less to check, which we'll do on this one. All right, so I'm going to set up my synthetic division. 1, 2, -8, -18, -9. Okay, so if I start with 1, bring down the 1. Okay, 2 plus 1 is 3. 3, it's -5. -5 is -23 after I add that. -23. So -9 minus -23 is -32. Okay, so 1 point is going to be 1, -32. So let's go ahead and erase that. Let's try -1. So if I try -1, I get -1 here. That's 1. -1 here. That's -9. That's 9. That's -9. That's +9. And that's 0. So yes, that worked. Okay, so now I have the point -1, 0. And I should be able to now, like I have four numbers here, so if I rewrite this, right, I'm going to get x cubed plus x squared minus 9x minus 9 equals 0. All right, and I should be able to do a factor by grouping here. Take out an x squared. That leaves me with x plus 1. Take out a negative 9. That leaves me with x plus 1. So my factors are going to be x squared minus 9, x plus 1, and then we already had an x plus 1, so that's going to be x plus 1 squared. All right, and so here again, I could continue breaking this x squared minus 9 up. That's going to be x plus 3, x minus 3. And then x plus 1 squared. So I mean, again, there's a multiplicity here at -1, that means. All right, so the other points that I know right now are, it's going to be -3, 0, +3, 0. And so when I'm graphing, okay, I would probably want to plug in -2 as well, so I know how low or how high I need to go, because I got zeros at -1 and 3, right? And so I probably want to know how high. I already have 1 there. Okay, I could plug in +2 as well. 0, having the y-intercept, that one's always easy, right? If you plug in 0, it's just going to be the constant at the end. So the y-intercept is -9. But it'd probably be helpful to plug in a number like 2 into here to get an extra point. All right, so if I did that really fast, okay, and you got to plug it into the original synthetic division, not one that's already been reduced. So 1, 2, -8, -18, -9. So if I do my synthetic division, multiply, add, multiply, add, multiply, add, -36. So -9 plus -36 is -45. So at 2, it's 45. All right. So when I go to sketch this, right, I'm going to plot my zeros. All right. So again, my zeros come from my factored form here. So -3, 3, and -1. -3, -1, +3. I know my end behaviors are going to be shooting up on both sides. All right, I know it's going to come down through here. All right, it's going to hit this, it's going to bounce, it's going to come way down. So yeah, I should have plugged in -2, not +2. Let me go back and do that. My bad, what's in between -1 and -3? I should have plugged in -2. Let me do that real fast. So -2, 0, 0, -8, +16. It's -2, +4. That's -5. So -2, -5 is a point that I really want. All right, so at -2, it's -5. Okay, so it's going to come down. And it's going to come through that. I don't know if that's the min or max. Again, this is just a sketch. It's going to come up. It's got to bounce off of this. The y-intercept is -9. It's going to come back down. It's going to come through this point right in here. It's going to continue to go way down. Okay, and it's going to come back up, come through here. All right, so that's my sketch. All right, let's see what it actually looks like. Okay, so you can see that my sketch is pretty right on. See how low it goes. If I could zoom out, see how low it goes. So if I type it in factored form, right? So I had x plus 3, I had x minus 3, and then I had x plus 1 squared. All right, so you can confirm I factored it correctly. All right, my sketch was pretty good. All right, it looked very similar. All right, look at mine, look at its, the real one here. Okay, so pretty darn close. So we were able to get a really good sketch, okay, from standard form without using technology, just by finding all the rational roots, okay, and really all the roots. All right, we got one more in here. So again, I'll speed this up here. What do we know? The degree is 4. There's 4 possible rational roots. M behaviors are both going up, right? It's a positive coefficient. My y-intercept is -5. Okay, on this one, it looks like I could use factor by grouping on this one. I could take out an x cubed and be left with 2x minus 5, take out a 1. So that's what I'm actually going to do on this one probably here. But if I go over to this next one and I say, what are my possible rational roots? Okay, so my possible rational roots here, it'll be plus or minus, and then it'll be 1 and 5. Right, and then I'm going to also get 1 over 2 and 5 over 2. Now my q is 2. So these are my possible answers. All right. Now if I need to do it, I'm going to do this one a little bit differently. Okay, I'm going to just go ahead and not use the rational root theorem. I'm going to use factor by grouping. Okay, so on this first one, I'm going to take out an x cubed. I just draw that line, cut it in half, right? So I'm going to get x cubed. That is going to leave me with 2x minus 5. On the next one, the only thing they have in common is a positive 1. Okay, so that's going to leave me with 2x minus 5. So here, I'm going to get x cubed plus 1, 2x minus 5. All right, so one answer is x equals 5 over 2. All right, so 2.50. This is the sum of cubes, so I could keep factoring this one. It's going to be x plus 1, and then it'll be x squared minus x plus 1. All right, so then again, this answer will be x equals -1. So I know -1, 0 is going to be so I got my two real x-intercepts. When I solve this, right, it's going to be imaginary. So I'm just going to use my shortcut to the quadratic here, which will give me x equals, okay, 1 plus or minus I rad 3 all over 2. So that's imaginary. So that doesn't even go on my graph. All right, so right now I only have 2 points. I got my 2 x-intercepts. All right, so I need more points in order to sketch this graph. I do know that my y-intercept is going to be 0, -5. So that might be good enough to help me graph. Okay, that's in between my 2 zeros. Okay, so if I go ahead and try to sketch this, right, what am I going to get here? Okay, oops. I'm going to plot my 2 zeros. So I got 1 at 2.5, got 1 at -1, and I know 0 is -5. I know my M behaviors are both going up. All right, and so I don't know what's going on. Like, is it coming through here? Okay, and then coming back up. I don't know how low it goes. Again, to be more accurate, I could plug in 1, I could plug in 2 to get a better picture of what's going on over there. All right, which would be smart to do. okay, if we ask you to graph it as accurately as possible. All right, so we look at the graph. Here's what's going on. Okay, it actually has a couple turns on it here. The imaginary ones are making it, okay, create some turns on it. So what again? So I want to type it in a factored form. So I had x plus 1, okay, and I had x squared minus x plus 1, and the other one was 2x minus 5. All right, so that was what I got when it was in factored form. As you can see, it matches up. So we're able to factor, we're able to find the zeros. Again, my sketch was not very accurate because I did not plot points in between. I only plotted 1 point, right? I should have plotted 1, I should have plotted 2, and then I might have been able to see some change in directions, okay, that were happening. So the more accurate your sketch is, the more points you want to plug in using the remainder theorem. So that's our desmos activity.